So as you've noticed, I mean, we have gone from super easy to super complex in this chapter. I mean, even from the reviews to now. So obviously they're getting harder and harder, more challenging, but the strategies are the same. A lot of the skills are the same. It's just you're seeing different types of problems. So now we're going to solve other equations, but basically ones that involve radical equations. Okay. So the steps for solving radical equations are basically straightforward. You isolate the square root, you square both sides of the equation, solve the remaining part for x, and check your answers. Again, when you have radicals, you have to check your answers. So we come over to this problem here. Let's start with this first one, and let's see how we might approach this, right? So we're going to come over to here, and we notice that we have this radical here, right? And the radical is right there. So what we're going to want to do, like the instruction said, is we're going to want to isolate that radical. We're going to want to get that square root of 15 minus 2x by itself. So I'm going to subtract x from, actually, instead of doing that, let me just add, right? I'm going to add the square root of 15 minus 2x to both sides. So that's going to leave me with x equals the square root of 15 minus 2x. So now I see that I have an x on the left and a square root on the right. And again, I want to get rid of that square root. So what I'm going to do is I'm going to square it. It's the easiest way to get rid of a square root is to square it. If it's a cube root, I cube it. If it's a fourth root, I raise it to the fourth power. And whatever I do to the left, I have to do to the right. So on the left, I'm now going to have x squared. And on the right, I'm just going to have 15 minus 2x. And then again, you notice, okay, it's an x squared. And so this is going to end up being a quadratic equation. So I'm going to, again, bring everything over to the left side. I'm going to add 2x to both sides, and I'm going to subtract 15. And I'm going to get that it equals 0, and I'm going to factor. So again, I know my factor has to multiply to negative 15, add up to 2. So that's 5 and minus 3. So I get x plus 5 times x minus 3. So I know that x is negative 5 and x is positive 3. And again, because I have square roots here in this equation, I do have to check it, okay? So, and it's not just a square root, it's that the variable is inside the square root. So I have to come here and actually plug it in. So I'm going to try negative 5. So negative 5 minus the square root of 15 minus 2 times negative 5 equals 0. So negative 5 minus 5, so negative 2 times negative 5 is 10. So it's going to be the square root of 25, which is 5. Okay, so this side looks like that. So I get negative 10 equals 0, and it does not equal 0. So guess what? Negative 5 doesn't work. And then I'll try the 3. So when I come back up here and I do the same thing and I substitute 3, I get 15 minus 2 times 3 is 6. So 3 minus, this is going to be the square root of 9. 3 minus 3 is 0. And so this one works. And so one of them was extraneous. This is the only valid solution in this problem. And so you're going to get these, and you just got to check them. Okay, so again, whenever you see a variable inside of a radical or a variable in the denominator, you have to check your answers. Okay, so now I notice here that, now this should not look like this, okay? You're not going to have the equal sign inside of a, inside of this thing. It's just not going to look like that. So what's going to happen here is that this actually should not be there. So let me rewrite it the way it should look. It should be x minus the square root of 3x plus 18 equals 0, okay? So what I'm going to do is I'm going to move the radical to the other side. So I'm basically just going to add this entire expression to both sides. And so that's going to give me x equals the square root of 3x plus 18. Once again, we're in this predicament. What do? Well, if we square this, we get rid of the radical, so we square both sides. So we've got x squared equals 3x plus 18. And again, we have a quadratic situation here. So again, I'm going to subtract 3x from both sides and 18. And the right side will clear out, the left side will get everything, and then I'm ready to factor. So again, my products have to be negative 18, and my sum is negative 3. So minus 6 and positive 3. So x minus 6 times x plus 3 equals 0, and that means that x is 6 and x is negative 3. And again, I have to ask myself, are any of these solutions extraneous? So I'll start with the positive 6. 6 minus 3 times 6 is 18 plus 18. So 6 minus the square root of 36, that means 6 minus 6 is 0, and yes, that's true. So 6 works. So we go here and we try the negative number. So again, we've got negative 3 negative 3 minus 3 times negative 3 plus 18 equals 0. So negative 3 minus, this is minus 9 plus 18 is 9. And so we get negative 3 minus 3 is 0, and we realize that is not. So this is extraneous. So again, one solution, x equals 6. That's it. Okay. We go to our third problem here, and we say, okay, notice we have a square root on the left. It's fully isolated, and then we have the 2x minus 1 on the right. So let me just rewrite it, kind of give myself a little space. So I know that to get rid of a square root, I have to square it. So I'm going to have to square the other side. So on the left, I'm going to get 4x plus 13. On the right, I'm going to have to multiply 2x minus 1 by itself twice, right? So I'm going to have to FOIL this. So when I FOIL it, I'm going to get 4x squared minus 4x plus 1. And so, again, I see it's a quadratic. I'm going to have to set it equal to 0. So I'm going to have to subtract 4x from both sides, and I'm going to have to subtract 13 from both sides. So my left side's going to be 0, and my right side's going to be 4x squared minus 8x minus 12. At this point, I'm going to factor this trinomial, although I notice that they all have a 4 in it. So I'm going to divide everything by 4, because why not, right? It's always better when you can simplify your terms. X squared minus 2x minus 3. And again, that's much easier to factor. That's going to be an x minus 3 and an x plus 1. So again, I'm going to get x is 3, and I'm going to get x is negative 1. So again, I have to go back into this original problem, right? I'm going to erase a little bit up here. Okay, just going to kind of erase this out. I'm going to go back up, and I'm going to have to check this answer. So I'm going to have to try 3 and see if 3 works. So I'm going to get the square root of 4 times 3 is 12 plus 13, and that's supposed to equal 2 times 3, which is 6 minus 1. So square root of 25 equals 5, and the square root of 25 does equal 5. So it works. So that number works. X is negative 1. It's the square root of negative 4 plus 13 equals 2 times negative 1 minus 1. I'm going to get the square root of 9 equals negative 3. And this is 3 does not equal negative 3. And so this is extraneous. So you might say, well, how come before when we did the square root of 9, we did plus minus? So it could be negative 3. But what happens with square roots is when the square root is already written for you, like you get a problem and it's just the square root of 4 and it's already written, there's only one answer. The bar is asking you for the positive root of the number within it. So when the bar exists, okay, or originally in the problem, they only want the positive root. When you put the bar in yourself, you have to take into account that there's 2 roots. You can't just limit it to the positive root. So because the bar was already there, they wanted the positive root. And so that's why that one's extraneous. So again, only one solution to that problem. And then let's go to this last one right here. Again, notice you've got this radical on the left. You're going to have to add 1 to both sides to isolate and get this radical by itself. So 6x plus 7 equals x plus 1, which is plus 2. Again, how do you get rid of a radical? You square it. So I'm going to have to square both sides. I'm going to get 6x plus 7 on the left, and I'm going to do x plus 2 times x plus 2, which is going to be x squared plus 4x plus 4. Again, notice it's a quadratic, so I have to subtract 6x and 7 from both sides, and I'm going to get x squared minus 2x minus 3. And when I factor that, it's going to be x minus 3, x plus 1. And so x equals 3 and x equals -1. Now, I know that these two work. I'm not going to check them. Really, in all the examples on this slide, the only ones that had extraneous solutions were 1, 2, and 3. And in an effort to save time on the video, I'm going to tell you I've already checked these off on my own, and there are no extraneous in number 4. However, you should always check. All right, so we're just going to get to more and more complex problems. Now, this one here, you notice you have 2 square roots. You have one on the left and one on the right. And so you can't keep them on the same side. You have to move them to opposite sides. And so I'm going to have to move this one over. So what I'm going to get over here, and this is going to make this problem quite complex, okay? So we got to take our time with this one. We're going to get the square root of 2x plus 3 equals 1 plus the square root of x plus 1. And we are going to have to eliminate the radical on one side to start. So I am going to square both sides. The left side will clean up really easily. It's just going to be 2x plus 3. The right side is going to get quite complex quite fast because I have to FOIL this out. So I'm going to do first times first is 1 squared, which is 1. Outer times outer is 1 times x plus 1, or square root of x plus 1. Inner times inner is 1 times x plus 1. And last times last is x plus 1 squared, square root of x plus 1 squared. So again, take your time to clean it up. Don't do too much in one step. I'm going to combine my middles. I get 2 times the square root of x plus 1. And the square root of x plus 1 squared is just x plus 1. So I'm still cleaning up my sides here, okay? So I've got 1 plus 1 is 2, right? Plus 2 times x plus 1 plus x. So I combine these together, okay? So now I see here, let me try to combine my like terms across the equal sign. Let me see if that will help me make this easier, right? So I'm going to subtract 2 from this side and this side, and I'm going to subtract x from both sides. And I'm going to see what that leaves me with, okay? You're going to see you're going to get x plus 1 equals 2 times the square root of x plus 1. So notice now I just have another square root on the right. So I'm going to keep doing what I do normally. When I have a square root, I have to isolate it and square it. So I know that if I divide both sides by 2, right, I can do, you know what, instead of dividing right now, let me just square the side. Let me just square both sides, right? Let me just take this, because I know to get rid of this radical, I could square it. So I'm going to square this side, okay? So when I do that, I'm going to get x squared plus 2x plus 1 equals 4 times, so 2 squared is that, and then the square root of x, or 2 squared is 4, and then square root of x plus 1 squared is just going to be x plus 1. So now notice I have no radicals left, which is great. If I distribute the 4, right, like that, now I just have a basic quadratic. We were able to, in these 2 steps, we were able to eliminate both radicals, but we couldn't do it at one time. We had to do it in different steps. So now I'm going to subtract 4x and 4 from both sides, and I'm going to get x squared minus 2x minus 3 equals 0. Again, I know my factors are x minus 3 and x plus 1. And so I know that x equals 3 and x equals -1. So all that work, but we finally got down to the solution. Now, again, we have to still make sure that it works. And so now we're going to check our answer. So we're going to come in here and we're going to try positive 3 first. So 2 times 3 is 6, 6 plus 3 is 9, minus 3 plus 1 is 4, equals 1. So square root of 9 is 3, square root of 4 is 2, and 3 minus 2, 1 equals 1. So 3 works. It's fine. So now let's check the next one. So we're going to try negative 1. So we're going to do the square root of negative 2 plus 1, or negative 2 plus 3 is 1, minus, and then the square root of negative 1 plus 1, so that's the square root of 0 is 0, and then minus 1. So we get 1 minus 0 equals 1, 1 equals 1, and it also works. So guess what? Both of them work. X equals 3, and x equals negative 1, and that's fine. Okay, and so it's a lot of work. I get it, but that is how you do it, and it's pretty straightforward. Again, it's just repetitive, a lot of doing the same thing. So this should make you feel pretty comfortable with some of the easier ones we started with. So again, remember, we're going to keep one. So I'm going to keep this one on the left, and I'm going to move the other one to the right. So I'm going to be left with square root of 2x minus 5 on the left, and then on the right, I'm going to have 1 plus the square root of x minus 3. Again, to solve these, I'm going to square the left, and I'm going to square the right. Right? I'm going to square it to get rid of that radical. Okay? It's my little squaring step. So now on the left, I'm just going to have 2x minus 5. And on the right, I'm going to actually square this binomial. Sorry, I got to do it a different color. Okay? So instead of square, I just expand it out so you can see it. So I'm going to have here first times first is 1. Outer times outer and inner times inner is going to give me plus 2 times x, the square root of x minus 3. And last times last is going to be plus the square root of x minus 3 squared. Okay, that's going to be foiled out when I do it. And so now I'm just going to start cleaning it up, right? So I get 2x minus 5 equals 1 plus 2 times x, square root of x minus 3. And this is going to be plus x minus 3. So once again, I'm going to combine my numbers. 1 and negative 3 are minus 2, plus 2x minus 3, plus x. Again, now we see that we have a radical, but the radical's now over here. And that's what we want to isolate. So I'm going to start moving everything over to the other side of the equation. Now to do that, I'm going to have to add 2 to both sides to cancel, and I'm going to have to subtract x from both sides to cancel it over there as well. So I'm going to get x minus 3 equals 2 times the square root of x minus 3. At this point, I can square my two sides, okay? Because again, that's going to get rid of that square root. So I'm going to get x minus 3 squared. I'm going to have to FOIL that. It's going to be x squared minus 6x plus 9. The right side is going to be 4. 2 squared is 4. And then the square root of x minus 3 squared is just x minus 3. So again, I'm going to have to FOIL. Or not FOIL. I'm going to have to distribute the 4. 4x minus 12. And then I'm going to have to bring everything over to the left because remember that this is a quadratic, so I have to get the right side equal to 0. So minus 4x plus 12. So I'm going to get x squared minus 10x plus 21 equals 0. Now my factoring, this is easy. This is going to be x minus 10. Or no, sorry, not x minus 10. X minus 7 times x minus 3 equals 0. And so I know that x is 7 and I know that x is 3. So solution-wise, I know that x is definitely 7 and x is definitely 3. Again, in an effort to save time, I've kind of gone back and I'm tweaking these videos, and I know that I've checked them and both of these solutions are valid. So we move on. So again, we just keep getting more and more complex problems, right? So I can really work with the right side or the left side here in number 7, but I personally like to always have the left side be the side that I'm going to square when possible. So for me, I want to add 2 to both sides. So I want it to read x square root of x plus 5 equals square root of x minus 1 plus 2. And then here I'm going to square my left and I'm going to square my right. So my left side is just simply going to be x plus 5. My right side, I'm going to have to kind of write this out to sort of help me with the foiling part here, x minus 1 plus 2. Okay, and so I'm ready to kind of do first times first. So first times, you know, and sometimes we like to have the radical at the end like I was doing. So I could have done 2 plus radical x minus 1. That might have been easier, but either way, it's the first term times the first term. So it's the square root of x minus 1 squared. That's first times first. Then I get outer times outer, and inner times inner is going to equal 4 times the square root of x minus 1. And last times last is going to be 4. So again, let me clean this out just a little bit. I'm going to get x plus 5 equals, square root of x minus 1 squared is just x minus 1, plus 4 times x minus 1 radical, plus 4. And again, here I'm going to combine the minus 1 and the plus 4 to give me plus 3, plus 4 times the square root of x minus 1. So now we see that we're left with, just like in the other ones, we've got this radical over here that we're going to have to square out eventually, but we have to isolate it first. So we start chipping away at the right side now and bringing everything over to the left. So we've got minus x and minus 3, right? That'll cancel these out, so minus x minus 3. And so here the x's cancel, which is kind of nice. We're going to get 2 equals 4 times the square root of x minus 1. So at this point, I can square the left and I can square the right. I'm going to get 4 equals 4 squared is 16, and square root of x minus 1 squared is just x minus 1. So I'm going to distribute, and I'm going to solve for x. So I'm going to start by adding 16 to both sides. So I get 20 equals 16x, divide by 16. And I'm going to get that x equals 20 over 16, which simplifies to 5 over 4. So that's a good one. And again, when I come in here and I go to plug these in, I shouldn't have any issues with 5 over 4. Again, you can always check yourself here, though, just to be sure. 5 over 4 is 1 1/4. Okay, and so I could do square root of, that's going to be 6 1/4 minus 2 equals 1 1/4 minus square root of 1 1/4, right? So I can kind of, let me do this, 25 over 4. Square root of 25 over 4 minus 2 is the square root of a fourth. So the square root of 25 over 4 is 5/2 minus 2, which is 4/2, equals square root of 1/4, which is 1/2. 1/2 equals 1/2, and yes. So it was a little bit of a pain to check it, but again, it worked. All right, and let's go to the last one on this slide. Let's try a different color. All right, so we come over here, and again, we're in the same boat. Now, this one's nice because it's already kind of set up for us. So what I'm going to do is I'm going to square the left, and I'm going to square the right. So the left side becomes 4x plus 1, and the right side, remember when I square it, is again square root of x minus 1 plus 2. Let me FOIL that out. It's going to be the square root of x minus 1 squared. It's going to be outer and inner, which is going to be plus 4 times the square root of x minus 1 plus 4. So again, notice it was very similar to the last one, that particular part. So again, we get 4x plus 1. Square root of x minus 1 squared is just x minus 1. 4 times x minus 1 plus 4. And again, I'm going to combine my -1 and my 4. So I'm going to get x plus 3 plus 4 times the square root of x minus 1. And then again, I notice that I have this, which I'm eventually going to square out. So I need to chip away and move everything out of that side. So minus x minus 3, that clears the side. Minus x minus 3 balances my equation. So I get 3x minus 2 equals 4 times the square root of x minus 1. I'm going to square this side and square this side. So now I got to FOIL the left side. So I know that's going to be 9x squared minus 12x plus 4 equals 16 times x minus 1 when I square the right. Let me distribute. So 9x squared minus 12x plus 4 is 16x minus 16. And so again, it's a quadratic. I have to set it equal to 0. So I'm going to subtract 16x and add 16 to both sides. So minus 16x plus 16. This side's going to equal 0, and this side's going to equal 9x squared minus 28x plus 20. So again, here, if there was a common factor, I would most definitely factor it out. Unfortunately, there's not, and I've got to try to factor this. So the factors that multiply to 180 and add up to negative 28, I know it's going to be minus and minus, and so it's going to be 18 times 10. And that makes sense there. So that wasn't too bad. So because it's, again, a is other than 1, I have to expand this to 4 terms. So 9x squared minus 18x minus 10x plus 20 equals 0. GCF of the first two, so I get x minus 2. GCF of the second one, which I get x minus 2. So I know my first factor is the GCFs, and then the times 9x minus 10 equals 0. So x minus 2 is 0, x equals 2. And 9x minus 10 is 0, 9x equals 10, and x equals 10 over 9. Again, to save time, I'm not going to check these because I already know that they're not extraneous. They're valid solutions. You should always check your answers, but again, I've already checked these, so I'm not going to do it on video. If it is any root other than a square root, you just raise it to the same power as the index. If the expression is raised to a fractional exponent, raise it to the reciprocal. So let's see what we mean by that, right? So again, if I have the cube root of 8, right, I know that I can undo the cube root of anything by cubing it, because cube root and cubed, let's say I was to solve it, cube root of 8 is 2, and 2 cubed is 8. So notice you go full circle. So anytime I have a cube root of something, if I raise it to the third power, whoops, those things will cancel out, leaving me with just the answer, okay? So the fourth root of 216, if I take it to the fourth power, it just equals 216, all right? So that's what they mean by that. If we say to you something like a fractional power, right, like x to the 1/2 power, they say multiply it by its reciprocal. And that makes sense. The reciprocal is the flipped version, right? Well, a number and its reciprocal, when you multiply them, always equals 1. So notice if I do x to the 1/2 power and I multiply it by 2 or 2 over 1, I'm just going to get x to the first, which is what I started with. Again, if I convert this to a square root, because x to the 1/2 is a square root with an index of 2, if I square it, we know that that equals x. So it's kind of the same thing. So just like over here, where I said the cube root of 8, and I said I could undo it by cubing it, and I'd get 8. If this is the same as 8 to the 1/3 power, that's the cube root of 8. So again, if I cube that, notice that that's going to be 8 to the 1 or 8. And so again, you can either use, put them in radical form and then use the index as your exponent, or you can keep them as a rational exponent, like a fraction, and just multiply it by the flipped version. So again here, when I look here, I see this problem and it seems like it might be overwhelming, but first thing, let's move them to opposite sides of the equal sign. So I'm going to have the cube root of this trinomial, 4x squared minus 4x plus 1, and I'm going to have equals the cube root of x over here, because I'm going to add it to both sides. Now I see I've got a cube root here, which I can cube, and I can cube this. So remember, as long as I do the same thing to the left and the right, I'm balanced. So my cube roots cancel, leaving me with just the trinomial within the radical, or the radicand, and then here these cancel, leaving me with just the x. So again, now it's just a normal quadratic. I want to subtract x from both sides because, again, it has to equal 0 to solve. So minus 5x plus 1 equals 0. And I'm ready to factor and solve this. I know my factors have to multiply to 4, add up to -5. So I know they're -4 and 1, -1. And I expand to 4. So minus 4x minus 1x plus 1 equals 0. GCF of the first two, GCF of the second two, And then the x minus 1 is my first factor. 4x minus 1 is my second. And I solve for each. So x minus 1 is 0, so x is 1. And then 4x minus 1 is 0, 4x is 1, and x is 1/4. And I've checked these off camera, and these are, again, valid solutions. There are no extraneous solutions here. So we move on to the next one. Again, it's raised to the 1/3 power. We're going to get 3x plus 7 to the 1/3 power on the left. And we're going to add 4x plus 2 to the 1/3 power over to the right side. And so now I've got my left side and my right side. They're both to the 1/3 power. Sorry about that. And so I'm going to cube both of them. Okay, and so I'm going to end up with 3x plus 7 on the left, and I'm going to end up with 4x plus 2 on the right, because again, these are going to multiply to the first power. So I'm going to move, this is linear function, I don't have any squareds, this is an easy one to solve. Move the x over to the left, and I'll get minus x plus 7 equals 2. I'll subtract 7 from both sides, and I'll get minus x equals minus 5, which means x equals positive 5. And again, it's a valid solution, no extraneous solutions here. A couple more problems here. Notice we have here the fourth root. So again, to get rid of the fourth root, I'm going to raise it to the 4th power. And so on the left side, I'm just going to get the fourth root and the 4 are going to cancel. I'm going to get x squared plus 6x equals 2 to the 4th power, which is 16. Again, it's a quadratic, so I will subtract 16 from both sides. A product of negative 16 and a sum of 6 is going to be positive 8 and a negative 2. So I'm going to get x plus 8 times x minus 2 equals 0. So x is negative 8 and x is 2. I've checked them both off camera, and they are valid solutions. And our last example for this page, again, it's the 1/4 power, so raise it to the 4th. And so I'm going to get 3x squared plus 52x equals 4 to the 4th power, which is 256. So I've got 3x squared plus 52x minus 256 equals 0. I can definitely, or actually I can't. There's nothing I can factor out of this. So I'm stuck with this one. It's going to be some large numbers here. I've got to have a product of negative 768 and a sum of 52. So this is going to end up being positive 64 and a negative 12. Crazy factors, you know, much more difficult than it needs to be. The first term stays the same. The middle term is going to change to 64x and minus 12x minus 256. GCF of the first two is just going to be x, so I'm going to get 3x plus 64. GCF of the second two is going to be a minus 4, which is going to be 3x plus 64. So 3x plus 64 is one of my factors, and x minus 4 is the other. And again, I'm going to solve. So 3x plus 64 equals 0. 3x equals negative 64. X equals negative 64 divided by 3. And over here, x minus 4 equals 0. X equals 4. And so these are my two solutions, which I've checked off camera, and both are valid. Again, you need to check them. Okay, and so here we go. We've got the left side and the right side. So now we have a little bit of a situation here because the expressions, the powers that we're raising them to, correct, are not exactly the same, right? So you might say, well, what do I do here? But let's say here on the left, x minus 3 to the 2/5 power, and over here I have 4x to the 1/5 power. Well, let's start by just getting rid of the fractional power. Let's raise it to the 5th, and let's do the same to both sides, right? That's still valid. I'm going to get x minus 3 squared on this side equals 4x to the 1. So notice that that's okay. I mean, I still have an exponent here, but I can now just FOIL this side out. This is x minus 3 times x minus 3 equals 4x. So x squared minus 6x plus 9 equals 4x. I can bring the 4x over, and I get x minus 9, x minus 1 equals 0, x equals 9, and x equals 1. And again, both values are valid. Okay, so again, just because I couldn't get rid of the entire exponent and get it to 1, that's okay. I at least could get it to something that was, agreeable to me, which was just a second power, a normal power, not a, a fractional power. So again, here I'm going to kind of do the same thing, right? Now, notice here I've got a little situation because the 3 is not being raised to that 3/4 power. So that's going to be a little bit tricky, right? So what I'm going to do is I have to kind of think about that. So I'm going to raise it to the 4th power. And I'm going to raise this one to the 4th power. And I'm just going to start by that. So I'm going to get 3 to the 4th power times x to the 3rd power, right? Because the 3/4, that part will cancel. And then this one here, when I do x to the 1/2 to the 4/1 power, I'm going to get x squared. So right now, I've got 3 to the 4th power is 81, x cubed equals x squared. So that's how I get there. Now, again, I know I have to solve this, so I'm going to have to bring the x squared to the left and set it equal to 0. And now I think you can kind of see a little bit of a pattern here. I could start, for example, by factoring out a GCF of x squared. I'm going to get 81x minus 1 equals 0. And so at this point, I could solve x squared equals 0. That means x equals, right, 0, 0. X equals 0. And here I got 81x minus 1 equals 0. So 81x equals 1. And x equals 1 over 81. And so I was able to find my two solutions, but it was, kind of a little bit different. But again, you can raise it to a power that will, at a minimum, get rid of your denominator. And by the way, these two answers do work because I have checked them. Okay.